बच्चों अब हम लॉज ऑफ मोशन के ऑब्जेक्टिव्स और समरी देखेंगे। इस चैप्टर में वी विल रीड अबाउट एरिस्टोटल्स फैलेसी, द लॉ ऑफ इनर्शिया, न्यूटन्स फर्स्ट लॉ ऑफ मोशन, न्यूटन्स सेकेंड लॉ ऑफ मोशन, न्यूटन्स थर्ड लॉ ऑफ मोशन, conservation of momentum, equilibrium of a particle, common forces in mechanics, circular motion, and then we'll solve problem in mechanics. Now I'll read summary for you. Aristotle's view that a force is necessary to keep a body in uniform motion is wrong. A force is necessary in practice to counter the opposing force of friction. Galileo extrapolated simple observations on motion of bodies on inclined planes and arrived at the law of inertia. Newton's first law of motion is the same law rephrased. Thus, everybody continues to be in its state of rest or of uniform motion in a straight line, unless compelled by some external force to act otherwise. In simple terms, the first law of is if external force on a body is zero, its acceleration is zero. Momentum v of a body is the product of its mass m and velocity v. P is equal to mv. Newton's second law of motion, the rate of change of momentum of a body is proportional to the applied force and taken place in the direction in which the force acts. Thus, F is equal to k dp upon dt is equal to k ma, where F is the net external force on the body and a its acceleration. We set the constant of proportionality k is equal to 1 in SI units. Then F is equal to dp upon dt is equal to ma. The SI unit of force is Newton. 1 Newton is equal to 1 kg meter per second square. The second law is consistent with the first law. F is equal to 0 implies A is equal to 0. It is a vector equation. It is applicable to a particle and also to a body or a system of particles, provided F is the total external force on the system and A is the acceleration of the system as a whole. F at a point at a certain instant determines A at the same point at that instant. That is the second law is a local law. A at any instant does not depend on the history of motion. Impulse is the product of force and time, which equals change in momentum. The motion of impulse is useful when a large force acts for a short time to produce a measurable change in momentum. Since the time of action of the force is very short, one can assume that there is no appreciable change in the position of the body during the action of the impulsive force. Newton's third law of motion: to every action there is always an equal and opposite reaction. In simple terms, the law can be stated thus: forces in nature always occur between pairs of bodies. Force on a body A by body B is equal and opposite to the force on the body B by A. Action and reaction forces are simultaneous forces. There is no cause-effect relation between action and reaction. Any of the two mutual forces can be called action and the other reaction. Action and reaction act on different bodies and so they cannot be cancelled out. The internal action and reaction forces between different parts of a body do, however, sum to zero. Law of conservation of momentum. The total momentum of an isolated system of particles is conserved. The law follows from the second and third law of motion. Friction. Frictional force opposes impending or actual relative motion between two surfaces in contact. It is a component of the contact force along the common tangent to the surface in contact. Static function Fs opposes impending relative motion. Kinetic friction Fk opposes actual relative motion. They are independent of the area of contact and satisfy the following approximate law. Fs is smaller than or equal to Fs maximum is equal to mu Sr, or Fk is equal to mu Kr. Mu S is the coefficient of static friction and mu K is the coefficient of kinetic friction. R constant characteristics of the pair of surfaces in contact. It is found experimentally that mu K is less than mu S. Now there is a table giving you physical quantities, their symbol, their units, their dimensions, and some remarks. First physical quantity is momentum, given by symbol P. Unit is kg meter per second or Newton second. Dimensions are m की power 1, l की power 1, t की power minus 1. Remarks, it is a vector quantity. Second quantity is force, given by symbol F. Unit is Newton. Dimensions are m की power 1, l की power 1, t की power minus 2. F is given by m into a, second law of Newton. Impulse, kg meter per second or Newton second. M की power 1, L की power 1, T की power minus 1. Impulse is given by force into time, change in momentum. Static friction, Fs Newton, same as force. Fs is lesser than or equal to mu Sn. Kinetic friction given by Fk, unit Newton, same, the dimensions are the same. Fk is equal to mu Kn. Please read points to ponder and do all the exercises, kids.